Hey everybody, it's Mr. Carr again. Today we're going to be talking about square root functions and inequalities. When we look at this, the graphs of our square root function, that's the first thing we want to look at. So what we're going to do is we're going to create a table to graph the parent function of all square root functions. So if we look at this is going to be my graph right here, and this is what I'm trying to look at here. Normally we like to start with like a negative number, but if I try to do this as like, let's say a -1, and do the square root of -1, that's not a real number. Okay, that's an imaginary number. I can't graph that. So we'll go to 0. Square root of 0 is 0, so that works. Square root of 1 is 1. Square root of 2 is a irrational number, so I'm going to skip that. I'm going to go to 4 because if I take the square root of 4 here, that's going to give me 2. Okay, and I'm just going to pick perfect squares. So if I do, like, say, 9, square root of 9 is 3. So you notice that the graph is going to start at 0, 0. Now I'm going to go 1, 1. I'm going to go 1, 2, 3, 4, and then 2 up, and then 5, 6, 7, 8 up, one more for 9. And then I'll go 1, 2, 3 up. So since my graph cannot go negative at all, we're actually starting right here. And I'm going to have this right here, and it goes forever that way. Okay, this is the parent function for the square root of x. So p of x equals the square root of x right here. Okay, so for our domain and range, we have restrictions. You notice if I say how far left does the graph go, it doesn't go forever. It stops here at 0. So I'm going to do that in two ways. I'm going to say that x is an element of the reals such that x is greater than or equal to 0. It can be 0, like this one right here, and can be anything more than 0. So it's greater than or equal to 0. As an interval notation, we are going to include 0, and we go off to the right forever. So I put a bracket on 0, parentheses on infinity, because infinity always gets parentheses. Range, same idea in the y direction. The lowest it goes is 0. It doesn't go any lower down here. So that means 0 is the minimum, and it's going to go up technically forever. It's going to keep building, increasing. So for my range, I could say that y is an element of the reals such that y is greater than or equal to 0. Or 0 to infinity again. My intercepts, I have the x and y intercept at the same spot. It's just 0, 0 in this case. Okay. For my end behavior, well, we don't really have, since it's not going forever in the left direction, I'm not going to say that x is approaching negative infinity because it doesn't. Okay. If you do anything, you want to say x approaches 0, then f of x also approaches 0. But as x approaches infinity, f of x approaches infinity. Okay, we're just describing what happens as I go way off to the right forever. It's going to keep going up forever. So that's the idea of our parent function here. That helps us to understand a little bit more of the transformation here. These right here are going to tell us the transformations of our graph. Okay, inside we have this x minus h. That causes what's called a horizontal translation. H is going to move it. H units right if h is positive. Okay, it's going to do absolute value units left if h is negative. Okay, we'll see how that works on some of these other ones. The k value that's on the outside is going to tell us if it goes k is k units up if k is positive, absolute value of k units down if k is negative. Okay, the last thing here is we talk about orientation and shape, and that's with the a value. If a is less than 0, you get a graph that's reflected over across the x-axis. So if you remember what it looks like, it looks something like this when we reflect it. If the absolute value of a is greater than 1, it's stretched vertically. And if it's in between 0 and 1, we get compressed vertically. So we'll see how that looks on some of these examples real fast. Graph the function f of x equals 3 times the square root of x minus 4 plus 2. Describe the transformations performed on the parent function. So here's what's happening. If we look at x, we can see how it goes in order. We do x minus 4. What that does is, if you think back to the parent function, it kind of looks like something like this. It starts at 0, 0. The minus 4 is actually going to move it 1, 2, 3, 4 to the right. Okay. There's also going to be a vertical stretch, but then the other important part is plus 2. So it's going to go up 2 from there. So here's what I know. I can kind of, I don't want to call it a vertex, but my starting point, we have +4, +2. Okay, so I go 1, 2, 3, 4 to the right and up 2. So what I have is I have a horizontal translation. Okay, 4 to the right. I have a vertical translation. Well, actually, I don't want to say that yet. I want to say, because it's kind of going in the order here, it does the translation horizontally. It vertically stretches, vertical stretch by 3. And then the last part is a vertical translation by 2. Okay. And let me be more specific. Vertical translation up 2. So we're just describing the horizontal left and right, vertical translation up and down, vertical stretch or compression by that factor. So to help with that factor, I'm going to plot a couple points. Okay. Remember some of those basic ones I did for my squared function. So if I have X and Y, I choose 0, 1, 4, and 9. Okay. If I do 0, well, actually, no, I don't want to. Sorry about that. I don't want to start here, actually, because I want to start at 4, because of the whole 4, 2 right here. If I plug that in, that's 4 minus 4 is 0. Square root of 0 is 0. Times 3 is 0. Plus 2 is 2. But then I'm going to go 1 more. And then I'll go 3 more. And that'll be enough. Okay. So if I do this one, this is 3 times the square root of 5 minus 4 plus 2. 5 minus 4 is 1. Square root of that is 1. Times 3 is 3. Plus 2 is 5. So I've got 5, 1, 2, 3, 4, 5. See how it's stretching up there? It's going to go taller curve than the parent function was. If I plug 8 in, that's 3 times the square root of 8 minus 4 plus 2. Okay, 8 minus 4 is 4. Square root of that is 2. 2 times 3 is 6. 6 plus 2 is 8. Right? Yeah, okay. So then that's, we got, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8 way up here. So here's what's going to happen. It's going to curve very tall like that. So there's my transformations, translation horizontally, vertical stretch, vertical translation. Let's talk about domain and range real quick. That's a little more space. I'm going to again do it both versions. X is an element of the reals such that if we look at this, it's 4 is the lowest it goes in the X direction. So X has to be greater than or equal to 4. Or as interval notation, we start at 4 and we go forever to infinity. In the Y direction, Y is an element of the reals such that Y is greater than or equal to 2. Since 2 is the smallest Y value goes and it's just going to go up forever, that's what it looks like there. And in interval notation, it's a 2, goes up to infinity. Okay, let's do, I think, one more example. Yeah, we'll do one more example on this one. So let's see what happens when we do a reflection in there. So again, if we look at the graph here, we know that it's going to be the +5 is going to go horizontal translation. Left 5, because it goes opposite what's inside the radical. Then we have a negative sign in front, so it's going to reflect over the x-axis. And then we have a -6 there. So we have a vertical translation down 6. Okay, so I can plot my first point. I'll make my chart right here just because I know I'm going to need that. 5 and -6. Sorry, -5, -6. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6 looks to be about right there. 1, 2, 3, 4, 5, 6. Yeah, close enough. Okay, so if you know how it's going to go on this one, you can kind of get a rough sketch. It's going to go something like this. To get a couple more points, I'm going to go, let's go 1 more, it's -4, and then 3 more is a -7. So this is going to be the negative square root of -4 plus 5, and then -6. So -4 plus 5 is a +1. Square root of that is 1. Then we have a negative of -1, or sorry, negative of 1 minus 6 is a -7. So it's going to go down here 1. Then I do a -7 in there. So that is going to be the negative square root of negative. Sorry, I don't. What am I doing? Sorry about that. I added 1, and I want to add 3. So -4 plus 3 is a -1. Sorry. So -1 plus 5 minus 6. Sorry about that. Okay, so -1 plus 5 is a +4. Square root of that is 2. Then I have a -2 minus 6 is a -8. So -1 goes down 1 more to -8. So here's my graph that looks like that. That's that horizontal translation left, reflects, vertical translation down. Now domain and range. Okay, when you look at domain again, left to right, we say it goes as far left as it goes is -5. So that is going to be x is an element of the reals such that x is greater than or equal to -5. Interval notation, -5 with a bracket. It goes forever to the right for infinity. For my range, y is an element of the reals such that y, look at this one, okay, the highest number it goes is -6. It's going to go down forever. So y is actually going to be less than or equal to -6 here. As an interval notation, I'm going to start it at -infinity because it's the lowest it goes is -infinity. And it comes up to a -6 is the highest value, and that gets a bracket. Okay, so that's it. We're just graphing those transformations and then taking care of that taking care of the graph, domain, and range, and talking about those transformations. So even without graphing, if I go down here, for example, stating domain and range, you should know based on these 3 things what it does. We know it's going to go left 1, down 4, and reflect. So without graphing, I can say, well, this is a interval notation or a set notation. X has to be greater than or equal to -1 because it's going to go left to right. And for my range, it's actually less than or equal to -4 because of the reflection and -4 being the highest. Okay, that's it for 6.3. Take care, everybody.